Okay, so now we're going to continue with points of inflection. On the last video, I showed you finding points of inflections analytically. So we looked at, in that case, where we had an equation. Now this time I want you to actually look at the graph and see if we can determine the points of inflections given a graph. Now I know in the last video that I made, in talking about the points of inflection, we were taking the derivative twice to find the second derivative, but this time we have a graph of the derivative. So I know the first thought is, well, how do I take the derivative? I don't know what the function is. All I see is a graph. So in this case, you don't actually have to take the derivative. We're going to actually use that chart that I gave you in class, where we have F here, where we have positive, negative, increasing, decreasing, concaves up, and then concaves down. I think that's the way I giving it to you. And then here we're going to have F prime and F double prime. So generally, if the function is positive, the original function is positive, not generally, but always if the original function is positive, then we don't know anything about the first or second derivative. If the original function is negative, we don't know anything about the first or second derivative. But if the original function is increasing, then the derivative is going to be positive. If the original function is decreasing, then the derivative is going to be negative. If the original function is going to concave up, then the first derivative is going to be increasing. And for concave down, the original function concaving down, then the first derivative is going to be decreasing. I know a lot of students get positive and increasing mixed up, but you can have a positive function that is decreasing. So if you look, and you'll see that in this example here, because this function, the derivative here is positive, but it's decreasing from 2 to, let's just say, I don't know, this is 3.7. It doesn't matter what I say that number is, but this is a positive function that is decreasing. So positive and decreasing are not the same, so do not get that mixed up. All right, and then lastly, we look here to see if the function is concaving up, then the second derivative is going to be positive, and if it concaves down, the second derivative is going to be negative. And in this case, we're going to actually be looking at this second row, the first derivative, because it said if the first derivative is increasing, then the function is going to be concaving up, and if the first derivative is decreasing, then the function is going to be concaving down. So we're going to actually use that to determine the points of concavity, and that's what we're going to be doing here. I mean, not determine the points of concavity, but determine if we have any inflection points. Okay, so let's look to see if we have any inflection point. I know a lot of students may want to say, well, 3.7 is the point of inflection, but it's not. 3.7 is actually a critical value because it's when the first derivative is equal to 0. But we are actually talking about points of inflection, so we need to be looking for the second derivative, and we need to see when the concavity is changing. So in this particular case, that is not going to be a point of inflection. So let's look here. You can see from 0 to 2 that F prime is going to be increasing, right? And that's from 0 to 2. And then if you look here, F prime is going to be decreasing from 2 to 0. I'm sorry, not 2 to 0, but 2 to 5. So if we see if the derivative is increasing, we know that it's concaving up. So we know that the original function f is concaving up from 0 to 2. But then from 2 to 5, it starts doing what? It starts concaving down. So we know that the concavity changed. It went from up to down. So we know that 2 is actually going to be our point of inflection, because the concavity is changing in that particular case. So in this case, so f of x has a point of inflection at 2 comma f of 2 because you can say f prime of x, f prime changes from increasing to decreasing. So this is going to be a point of inflection when x is equal to 2. So let's look at one last example. We'll go through that real briefly. I'm not going to do much writing on this. I'm just going to talk this one through, and then we'll be done with this one. So this is the graph of the derivative again. So in order to determine points of inflection when you have the graph of the first derivative, you're basically just looking to see where the function is increasing and decreasing. So if you see here, we're increasing from 0 to 2, and then we're decreasing from 2 to 4, and then we're increasing again from 4 to 5. So since the first derivative went from increasing to decreasing, we know again 2 is going to be a point of inflection, but then it goes from decreasing to increasing at 4, so I know that 4 is going to be a point of inflection. So that's pretty much sums up looking at points of inflections with the graph, and the other video is going to be when we have points of inflection without a graph, when we have analytical situations. Of course, it's possible to look as well for possible points of inflection through table, but that's more than likely not going to be tested. So these are the two things that I do want you to focus on. Okay, thank you and have a great day.